Welcome everyone to Ready Steady Charge. I am Solomon. Today we are going to talk about some electric vehicle basics. For those of you who are already familiar with EVs, this will be a little bit of a review. For those of you who are new to EVs or are interested, I think this will be very helpful. So today we're going to talk about some basic fundamental numbers and units of measurements that are very important in talking about EVs, in understanding EVs, and knowing what numbers mean. We are going to talk about 4 different units of measurement. The first one is voltage, measured in volts. Second one is current, measured in amps. The third one is power, which is measured in kilowatts. And the fourth one would be energy, measured in kilowatt hour. I will go through each one of these in the simplest of terms and give you some understanding to where they're found and how they're used. Let's start with voltage. Voltage is the potential difference between 2 points on an electric circuit. Now, voltage itself is measured in volts. And how you can imagine this as a concept is if you have a water tower and all the water is stored on the top, you got a pipe that's running down to the ground. The difference in energy in the stored water versus the ground can be considered as what voltage is in terms of electricity. Next, let's look at current. Current is measured in amps. And current measures the flow of electricity at a certain point in the circuit. If you go back to our water tower concept, the current would be the amount of water flowing through the pipe. And you measure that at any point in the pipe. Now, voltage and current are very important because they are the basis for how the measurement of power is calculated. Power will be measured in watts, and in electric vehicle terms, most likely kilowatts, because you'll be dealing with thousands of watts instead of just, a few watts. So a watt equals to voltage times current. So volt times amps would equal to 1 watt. Now, kilowatt is a measurement of power. Now, what is power? I look at power as a measurement in time of energy doing work. So horsepower is also a measurement of power. In fact, you can directly convert kilowatts to horsepower by multiplying kilowatts by 1.3. At last, we come to the measurement of energy, kilowatt hour. There are other ways to measure energy, but the most useful one in electric vehicles is the kilowatt hour. In fact, the unit itself is very useful in describing the concept of what it's trying to measure. So, for example, if a power source is able to supply 100 kilowatts of power, and that lasted an hour, that means the power source has supplied 100 kilowatt hours of energy. If you take 100 kilowatt hours of energy and you supply 50 kilowatts of power, you can sustain 50 kilowatts for 2 hours. So you see how that works. The concept of energy measured in kilowatt hour is just a sustained power source over an hour worth of time. So that's how you can understand the difference between the measurement of power, which is kilowatts, to the measurement of energy, which is kilowatt hour. We've talked about the basic concepts of voltage, current, power, and energy, measured in volts, amps, kilowatts, and kilowatt hours. Now, what does that mean in the real world? Where are these measurements being used? Voltage and current are not numbers that you would generally use on a daily basis as an EV driver. Taken on their own, each of these values are acting more like technical data for either your vehicle's battery or for a charging station. What's more commonly used is combining voltage and current together to find a measurement of power in kilowatts. There are two general scenarios where a kilowatt is a very useful measurement. The first one is related to charging. So how many kilowatts is your charger supplying and how many kilowatts is your car pulling? That's very important. The other measurement in kilowatt is more like measuring your horsepower. So what's the performance of a vehicle like? Because a horsepower and a kilowatt can be converted to each other. So a very sporty vehicle would have a very high maximum kilowatt output, just like how a very sporty internal combustion engine car has a very high horsepower. The other very useful measurement is energy in kilowatt hours. There are two scenarios where this is most commonly used, and arguably the most important one is determining how big your battery is, which means how much energy does it store. Large capacity batteries would have higher kilowatt hours, which means more energy. Lower capacity batteries have less kilowatt hours, which means less energy. Typically, a plug-in hybrid battery is quite small, hovering around 10 kilowatt hours. Some are a little bit over, some a little bit under. While the largest consumer vehicle batteries existing today are hovering around 100 kilowatt hours. The other important use of energy measured in kilowatt hours is how much energy did the charging station put into my battery during a specific charging session. This is important if you want to gauge how efficient your charging session was. And also, there are some charging stations that decides on the cost of a charging session based on how much energy you've taken from the charger. Now, a disclaimer here is that around Alberta, most level 3 chargers determines cost based on the amount of time you're plugged in. But there are some that use energy as a measurement instead. That covers the basics. And in fact, I am actually charging right now on a level 3 charger located at Londonderry Mall. How about we take what we learned into the real world, and I'll show you what all these numbers mean. As I am charging, the car will show me how much power the charger is supplying to the vehicle. We are getting 48 kilowatts. So that's a power of 48 kilowatts into the vehicle. That's pretty good for this charger, considering this particular charger tops out at 50 kilowatts. Now let's go to the charging station screen and see what the voltage and current is like. Now it measures it both in kilowatts and in voltage and current. 397,125. Alright, that should make 49 kilowatts. Here is my handy dandy calculator. Let's make some calculations. So what we saw was 397 volts multiplied by 125 amps. Wow, look at that. It's 49,625 watts. That means it's just under 50 kilowatts, so 49.6 kilowatts. Looks like the charger is telling us the truth. I just unplugged and stopped the charging session. And looking at the final report for the charging session, you can see the charger reported an energy output of 52.1 kilowatt hours. I stayed here for quite a long time. I got the time because I was making this video. And I charged my car starting at about 22 to 23% battery, and I finished with 93% battery, so basically 70%. Normally, I wouldn't stay at the level 3 charger for this long, but again, I was making the video, so I just stayed as long as I needed for the video. Thank you everyone for joining me today on this EV basics video. I hope it was informative and helpful. My name's Solomon, and as always, see you on the next one.